this. I'm gonna stop other people's sharing. All right. Okay, this is what we have done yesterday on this word check. So we have covered some data structures yesterday. We have covered lists, right? Which is technically just, okay, sorry. Let's slowly go through this, right? Data structures are collection of data, right? So we have a lot of different information around the world. We have like name, age, mailing address, credit card details and stuff, right? So if we want to go through every single piece of information to access or maybe to manipulate, all right, that piece of information, it may take a lot of time, right? So we tend to group them together before we oh, sorry, I need to actually start recording, sorry. Okay, all right, so let me just repeat. So basically the idea of data structures are to group information together so that we can access and change them easily, right? So there are 4 built-in data structures in Python, right? There are lists, dictionaries, sets, and tuples, right? Yesterday, we have gone through lists and some of its methods, such as your list, dot append, dot pop, and dot insert, right? And for this, one of the most important thing is your index numbers, right? So the first element is always indicated by the index number of 0, right? Remember this, list always starts at the number 0, okay? All right, so that's list. And then we have also talked about dictionaries, right? Dictionaries are a bit different from lists, right? So list takes into consideration your index numbers. However, for dictionaries, they do not care about your index number, right? What do they care about then, right? They care about your key. Okay, what is the key that's holding that piece of information, right? So each key is allocated a value, right? We usually call this the key value pair, right? They always appear as a pair, right? And this pair is connected with a colon, right? So we always write it in this particular manner: key, colon, value, right? And this value can be anything, right? It can be your integers, floats, strings, lists, dictionaries, whatever, right? Anything can be a value. It can even be a function, which is something that we're going to go through later on. All right. And always remember this, before you move on to your next key, right, you need to have a comma, right? So this trailing comma tells the computer that, hey, this is the end of your first key, right? We move on to the next key. Okay, this information over here is just me trying to demonstrate that you can put in a lot of different information in the dictionary. All right, a key can hold another dictionary, all right, or what we call the nested dictionary. Okay, whenever you see the word nested, that means there is something inside something, right? Nested list, nested loops, all right, a loop inside a loop. It's called a nested loop. Okay, and you can also put a list inside a dictionary. All right, so when you have data structures nested within another data structure, you need to actually enter a few layers, right? So what do I mean by entering a few layers? Let's say if I were to access the word laksa, oh, my favorite food, okay? I will first need to do char dictionary, which is the variable name, all right? We need to first go into the level of favorite food, okay? So I will need to square bracket, favorite food. So at this point, I'm actually referring to this particular dictionary over here, right? But I'm not at a level that I can access laksa yet, right? So I need to go one level deeper to access Eastern, right? So I need to do square bracket, Eastern, like this, right? And this will refer to laksa, right? So I just need to print it out, and I'll get laksa. Okay, so whenever you have something that's nested within a different data structure, you will need to do multiple indexing, right? Very similar to your list as well. Okay, if you have a nested list, such as this powers over here, right? If I were to get superhuman strength, I would first need to go into powers and refer to the index of 0, right? This will give me superhuman strength, right? I'm referring to the index number 0 of powers. Excuse me. Okay, so we have roughly covered lists and dictionaries, but yesterday I do not have enough time to cover sets and tuples, so I'm just going to briefly go over what are sets and tuples. Okay, let's start with sets. Sets are basically a collection of data that do not allow any duplicate of information. Okay, so how do I create a set, right? I can simply use, let's say I call it a num set variable to temporarily hold on to this set for me. All right, we use the set function and let's create a set out of the num list. Okay, and as you can see, the set only contains 4 pieces of information, 1, 2, 3, and 4. All right, as compared to the list above, which gives me 14 characters. All right, the set only allows 4 characters because anytime the character is being duplicated, it will not be recorded in a set. Okay, so this is useful when you want to find out about some unique characters, right? How many unique characters are there in this collection of data? Okay, and that's that for set. For tuples, tuples are like lists, except for the fact that they are not mutable. Okay, what is mutable? Let me just quickly go through this again. Let's delete all of this. All right. Um, remember, we can actually change a certain element of the list simply by doing this, right? Num underscore list square bracket 6, assign a new value of, let's say, maybe hello world. Okay, I can do something as simple as that, right? However, if you were to create a tuple, okay, a tuple is created in this manner. Let's see, using a round bracket, okay, we can do maybe 1, 2, 3, 4, 3 again, and maybe some other numbers like maybe 5, 50. Okay, right? If I were to do this, this is actually a tuple, as you can see over here. Let's not call this num list, which can be a bit confusing. Let's call it num tuple. All right, if I were to get num tuple to change its value, you see that, hey, tuple does not support item assignment, right? It doesn't allow you to change the element in the tuple, in the collection of data. So when is this being used? All right, let's say if you have a list of objects, all right, a list of information, and you don't want anyone to tamper with it. You don't want anyone to change the information that's inside. You can use a tuple, right? Because no one can now change anything that's inside. Okay, you can add things onto it. All right, you can refer to it by its index number. It's exactly the same like this, right? However, you cannot change the information that's inside. All right, so that's that for tuple. All right, so tuple is created using round brackets. Okay, so curly braces, we use it for dictionaries and also for sets actually, but I don't want to introduce it here because it may be confusing, right? So I'm just going to tell you this right now, all right? Brackets can use to create tuples, all right? For lists, we use square brackets, right? So num list, oops, sorry. Okay, num list 2 is equal to square bracket. This is to create a list. Num dictionary 2, this is to create a dictionary, and we have tuples. Let's see if I can create an empty tuple. All right, sorry, this needs to be removed. Okay, you can create an empty tuple like this as well. Okay, so this is how we create the built-in data structures in Python. All right, built-in means these data structures are readily available when you install Python in the first place, right? They are built in. You don't need to import any modules. Okay, so for today, ooh, can we use set for dictionary 2? I'm afraid you cannot. Okay, but we can try it out, right? The best way to find out is to try it out. Okay, let's say for example, let me go all the way back. This might take a while though. Okay, let me try to do a set on character dictionary, right? To see if it works. All right, my sense is it doesn't work, right? So let me just do it. Let's try it out. Okay, it does. All right. However, it will only take in the keys, right? It will only find out the unique keys. And this is not very useful because when you're using a dictionary, right, you wouldn't have duplicate of keys, right? When you have the same key twice, the new value will just replace the old value. So this is not very useful. Okay, so usually set are used in conjunction with list to find out about the unique characters in a list. All right. Okay, so for today, we are going to talk about functions. Okay, how do we define our own functions? All right, a bit of scope. And at the end of the day, we are going to talk a bit about AWS as well before you move on to tomorrow's class on Management Console, right? A quick introduction on what is cloud computing and what are the services offered by AWS. Okay, so once you're ready, let's go. I'm going to move on to a blank page over here. So today's topic is functions and scope. All right, so the first keyword that we are going to go through today is the word DEF, okay? DEF stands for define, all right? We can define our own functions. Sometimes other people's modules, right? Other people's function, for example, random.rantin, time.sleep, may not be sufficient to execute your own program, right? So you need to define your own function. Now, why do we want to define our own function? It is to achieve an idea of abstraction. At this point of time, abstraction, as the name suggests, may be a bit abstract to you guys, right? So as we program along the way, as we code later on, I will explain to you why and how is it supporting the idea of abstraction. Okay, so I am going to move on to my repo. Okay, let's create a new repo. Okay, this is for day 4. Python, AWS train, not WS, AWS training day 4. Creating repo. Let's go. Okay, let me just hide these files for a bit more screen real estate. Okay, so Python is up. Let's talk about how to define function, right? So to define a function, we must first indicate the keyword DEF, okay? After the keyword DEF, by the way, if my screen is a bit too small, do let me know so I can zoom in a bit more, okay? After the word the DEF, all right, we need to define what is the name of this function. All right, think of it like a variable name. You want a computer to give it a very meaningful name, right? So that people, when they use this function, they will know a rough idea of what it's gonna do, right? A very good example is when you import the random module and you call the function randint. All right, one look at the name, you will realize that, hey, this is giving me a random integer, right? It's very intuitive, okay? So when you name your functions, all right, you will also name it in such a manner, okay? So this is where we name our function, right? I'm just gonna call it func name for now, all right, to indicate that this is where you input your function, all right? And after that, in the brackets, this is where you indicate your parameters, right? We call it params. Now, what are parameters? Parameters are like variables or information that you want to pass into this function. Okay, we have done this a few times, all right? If you remember, when we call our random.randin, we will need to pass in some numbers, right? So what is going on over here is when they define the function of randin, all right, they have indicated that, hey, this function takes in 2 parameters. All right, 1 and 6 in this case, all right? This is me trying to tell the user that, hey, if you want to use this function, you need to give me 2 pieces of information, all right? And I can even increase this up to 3 pieces of information, right? So it's up to you to decide how many pieces of information that you need when you use this function, right? For now, I'm just going to keep it as 1, right? After that, you need to use your colon. All right, so this colon is to indicate that, hey, what's going to go on next is going to be inside this definition, all right? And here is where we define what the function should do, okay? So let's say, for example, print hello world, okay? Let's say this function is just called hello, and there is no parameters, okay? Because it's just going to print a hello world like this, okay? Now, when we define this and when I run the code, nothing's going to happen, okay? Because currently we are just defining it, right? It's like me drawing on a piece of paper, hey, I'm going to do this, but I haven't do it yet, right? This is just defining it. So in order for the computer to execute this function, we need to call it, all right? The word here is to call it. So how do we call a function? All right, we have covered this on day one itself. You just call the function name followed by a bracket, okay? And when we call the function, it will do whatever that's inside the function definition, right? In this case, hello world, okay? Now, I'm going to demonstrate what I mean by using some parameters to pass in information to the function. Let's say, for example, you want to create a function hello that greets whatever name that you put inside the function, okay? So I'm going to put in here name, all right? Assume that this name is a variable that is going to be passed inside this print function, pass inside this hello function, all right? So instead of hello world, I can do f hello name. All right, so whatever information that I pass in here as the name, it will appear here when I print the hello, okay? What do I mean by that? Let's say, for example, I want to say hello Eric. All right, I'm passing in Eric as an argument. Okay, now a bit of a jargon over here, not to confuse you guys, but these are the jargon that's being used when you are learning programming, right? When you pass in an information upon calling the function, this is called an argument. All right, not that you're trying to argue with the computer or something, right? They just call it argument. And when you are defining a function and you're telling the computer that it requires an input, this is called a parameter. Okay, so when you're defining a function, you are defining the parameters that needs to be given by the user when they call it. Okay, and when the user call the function, they are providing the arguments. Okay, now when you indicate that there must be one parameter, then there must be one argument. Okay, this is a very strict point in Python, right? Unlike other languages, right? So in Python, when I say I need one parameter, that means you need to use it with one argument. Now, what happens if I don't, all right? If I don't do this, ta-da, you are going to have an error, type error, right? Hello as a function is missing one required positional argument, right? I am not giving the argument that it requires, okay? So we will need to provide the argument. Okay, so let's see. Hello name. All right, so this, when I do this, it's gonna say hello name instead, right? If I do hello Eric, then it will give me hello Eric, right? So it depends on what information that you pass in as an argument, okay? So what is an indentation? An indentation is achieved by clicking on your tab key. Okay, remember when you're writing your if statements, right? If a condition, all right, you have your colon followed by an indentation, right? This space over here is called your indentation. Before you tell the computer what are the actions required. Okay, there are a few things that needs to use this indentation, right? When you're writing a while loop, when you're writing if statements, and when you're defining a function as well, right? You will require this indentation, right? Indentation is telling the computer that, hey, these lines of code, right, is inside this if statement or inside this while loop or inside this function definition. Okay? All right. Now, so this is the idea of defining a function. It's easy as that, right? So I just use the def keyword, provide the function name, all right, provide the necessary numbers of parameters, okay, and then I tell the computer what to do when this function is being called. Okay, and when you call the function, you need to provide the necessary number of arguments. Okay, now we need to move on to a harder part of this, right? The next part is to talk about scopes. Excuse me. So when we talk about scope, we are talking about where we can access the variables. Okay, when you are declaring a variable on the main program itself, let's say for example, score is assigned a value of 0, right? This score, right, is in a global scope, all right? The entire program can see it, okay? However, when you when you initialize a variable that's inside a function, okay, this is a local scope, okay? That means it will only exist within this definition of function, all right? And it will only exist when the function is called, right? At the end of the function call, this variable will cease to exist. That means it will die off, okay? What do I mean by that? Let's try out, okay? So let's say, for example, I have a score inside this function, okay? I say I will print, I have score equals to 0, and then I try to run, okay, let me just remove this, run hello, okay? And at the end of hello function, I try to print the score. Okay, it will tell you that your score is not defined, all right? But you will try to tell me that, hey, I have run the function hello, right? The score should be initialized, right? Why can't I refer to it? Okay, like I mentioned earlier, any variables that are initialized within a function scope, all right, is considered local. That means at the end of the function call, all right, when this is done, the variable will die off. Okay, so that's local. All right, now let's take a look at global. Okay, so global variable. Okay, score is 0. Can a function, all right, refer to a global variable? All right, let's try this out. Okay, I will print hello, and also I will print score just to double confirm. Okay, when I do this, I will have two different prints. Okay, why do I have two different prints? One from the hello function being called, right, which print the score, and one from my own print score. Okay, so even if I delete the last print score and I run this again, I will still be able to get the 0. All right, so that tells you that a global variable can be accessed from anywhere, right? You can see it, right? And then you can print it out, you can use it, right? But can you change it? Let's try out. Okay, let's say for example, I want to do score is assign score plus 1. All right, very simple, right? I'm trying to get the score, right? Here at this point, I can refer to it. I plus 1, I assign to a score, I print it out. Okay, let's see. And also just to be sure, I print another score that's outside of the function. Okay, it will tell you that there is an unbound local error. Wow, new error to us, right? So it's telling you that, hey, this local variable score is referenced before the assignment. That means I am trying to refer to something that I have not initialized in the function scope. Okay, yes, I can try to get this information, but I cannot assign it like this. All right, I cannot change the global variable directly using the function. Now, can there be another way around to change it directly? Yes, there is, all right? So if you were to change it directly, you must first tell the function scope that you are going to use the global score, all right? So this global keyword, all right, followed by the name of your variable is going to tell the computer that, hey, I am going to use this variable at the global scope and I'm going to change it directly. Okay, so when you do this and when you run it, you'll be able to get a score of 1. You have successfully increased it by 1. Okay, now, quick error over here. This is not the best practice. Not best practice. Okay, so now, why is it not a best practice? when you are programming a certain program, all right, maybe in the future when you're working on a big project, okay, you do not want to directly change your global variable using a function. Now, why is that so? Imagine you have a lot of different functions, okay? And when one of them is accidentally being executed, your global variable changed, all right? And you as a programmer, you do not know which function it is that is causing this change, right? So you have to go through one by one, all right? So the best practice is to not touch the global variable directly, okay? So how do we then do it? The better way to do this is, instead of changing it directly like this, all right, we pass in the score as a argument, okay, as an argument, all right, then we change it, and then we, instead of printing it out, we use a new keyword, right? We are learning a new keyword today, right? It is return. Now, I've used this keyword a few times in the past few days, right? Like the operator returns you a new value, right? And casting function returns you a new value. When you see the word return, that means the computer gives you a new value, okay? Gives you a value, right? What do you want to do with it? It's up to you, right? You can use operations onto it. You can save it in a variable if you want to, all right? You can do whatever you want with it, but this information is given back to you. Okay, when you print a score, this function doesn't give you anything, right? It just prints on the screen. It doesn't give you any information. But when you return a score, this information is given back to you. Okay, so in this case, all right, we have a score variable that is being passed in as an argument. All right, whatever number it is going to be increased by 1 and then returned back to us. Okay, so how do we then update our score? We will just do this, right? Score is equals to, all right, hello maybe not be a good name. Let's call this update. Okay, update score. All right. So when I play this, all right, you wouldn't see anything. Now, why wouldn't you see anything? Because the score has been returned and saved in the score variable. All right, but we didn't do anything with it, right? We need to print it out. Okay, there you go. You have 1. Okay, now some of you may question, why do we need to learn about functions? Okay, functions is supposed to make our life easier. Okay, let's say for example, you're trying to program a game, all right, and you're gonna have a few methods to update your score, right? You can either update by eating a mushroom, right? Update by eating or beating a piranha plant or something like that, right? So different updates may have something like this, right? Update by mushroom, right? Instead of increasing score by 1, I increase the score by 10, right? Then I have another function that says update by fire plant. Okay, another score. Okay, and then do score is equals to score plus, let's say maybe 20, right? Return score. Okay, and then in a bigger program, I will say something like maybe if Mario eats mushroom, right? Then I can activate. Score is equals to update by mushroom score. Okay, and then maybe for piranha plant, I can say if Mario beats fire plant, score is equals to update by fire plant. Oops, my computer is lagging. Fire plant. Okay, now why do I want to do this? Right? So in the future, right, if I were to change this program, let's say now by eating I want to do a simple patch, right? I imagine some of you may play some online games such as Dota and League of Legends and stuff, right? When you want to do a simple patch, all right, instead of going to all these simple lines to update the score, I can simply go to my function and just change the score. All right. By changing this one function, any other part of the code that uses this update will now increase by 15 instead. Can you see the convenience? that it provides, right? Instead of changing one by one, it changes all for you. Okay, and fire plant as well, right? So now instead of increasing by 20, I want to double it up, right? So I want to buff this score. Okay, now it becomes 40, right? Everything will change as well. Okay, so this is the idea of abstraction. You want things to be as generalized as possible, right? That means if you have multiple actions that can be generalized under one function. Okay, maybe that's not the best of drawing. Okay, generalize. You would want to do that. Okay, and you just pass in the necessary argument, right? Maybe this one is to pass in your score. This is to pass in your time and stuff. All right. This is the idea of abstraction. We want it to be as high level as possible, right? So I don't really need to know what's happening behind, right? I just need to type the code, update by mushroom. I will know that, oh, this is going to update the score accordingly, right? What's going to happen inside? I don't really care. Okay, unless I want to perform some patches, then I would look into the function and change accordingly. Okay, so this is the idea of functions and scope. All right, so I'm going to take a look at the chats. Let's see. Okay. Can I have a copy of the sample exercises? Which day is it, Rico? I can actually, yeah, you can actually search for my Replit links. I can paste it all here. Okay, let me just try it. Wait, this is version control. Yeah, you can use the same link that X has posted to everyone, and we just change the, the number from 4 to 3 to 2 to 1 to have a look at the previous code that I've done. Or you can also visit the recorded videos, right? Okay, I am going to actually revisit our scissors, paper, stone really quickly. And wow, thanks X for posting all the different links, right? So I'm actually going to revisit my scissors, paper, stone. All right, and teach you guys a bit on how to use abstraction. Okay, I'm actually gonna just click on the link that X has provided. Pretty cool. Saves me a lot of time. Thanks. Scissors, paper, stone should be on day 2. Yep, it's on day 2. Okay, cool. Okay, so if you remember, we have done scissors, paper, stone on this particular day, right? Training day 2. I'm gonna make a bit of changes over here, okay, to kind of demonstrate the use of function. All right. So if you remember, one of the parts, we have actually said that, okay, which part is it? Okay, this is the part where I introduce my weapon and stuff. Okay, I've selected a weapon. Now at this point, right, this print over here would have just selected, would have just print the number 1, 2, and 3. Okay, now as a gamer, I don't feel like it's very prompt, right? What's the number 1, 2, and 3 gonna signify, right? It's gonna show me, do I have to decipher it myself to say that, oh, 1 is scissors, 2 is paper, and 3 is stone? Okay. If I were a programmer, I would have programmed something to actually tell my user that, hey, if my player weapon, okay, sorry, player, not score, weapon is equals to 1, okay, I would print player has chosen weapon 1, right? And then if elif my player weapon is equals to 2, my player has chosen, no, sorry, not weapon 1. It wouldn't defeat. Scissors. Sheesh, what's wrong with me? Okay, scissors, paper, and stone, right? Now imagine this, if I were to do this for my computer as well, right? I'm actually writing the same set of code, right, twice, okay? And that's actually taking up a lot of time and it's not very intuitive, okay? What I can do is I can abstract this and provide a single function definition that can be used for both the player and the computer. Okay, so let's do this. All right, so the idea is I'm gonna print F and I'm gonna say player has chosen weapon check as a function and computer has chosen weapon check. Okay, weapon, and this is player weapon. Okay, now what am I going to do over here is I'm going to define a function called weapon check, and in this function I'm going to pass in the argument of the player's weapon. All right, which is the number from 1 to 3. Okay, and based on what is the number that's given, all right, it will return an information back to me that I can show on this screen. All right, what is the weapon that's being selected? Okay, same thing for my computer. All right, and because the computer also uses the same format, right? 1 is scissors, 2 is paper, 3 is stone. Okay, it can use the same function. Okay, not as if the computer is using a different format for that, right? A computer's 1 is still a scissors. Okay, so let's define a function. Usually when we define functions, we do it at the top of the program. Okay, so let's define this weapon check function. And it is supposed to take in a parameter, right? It is supposed to pass me my player weapon or my computer weapon, right? So I'm just going to put in a parameter name called weapon. Now, this parameter name and this argument name, okay, doesn't have to be the same. Okay, this is just an arbitrary name variable that you're going to use inside this function scope, right? You're going to use somewhere in this scope that you will use a weapon as a variable. Okay, and I'm going to demonstrate this right now. Okay, if weapon is equals to 1, okay, this is scissors, right? So I'm going to return scissors. Okay, and when I say return, all right, this piece of information scissors will be passed back to this area over here, right? This weapon check player weapon if it is 1. Okay, and then I have elif weapon equals to 2. I can return paper, sorry, with capital letter. Okay, and last but not least, I can just put else. Now I can safely put else over here instead of elif weapon equals to 3, because I know for sure that if you are selecting any other number besides 1, 2, and 3, you cannot pass through this while loop. There is no way that you can pass through this while loop. So when you pass through this while loop, I can safely say that your player weapon must be 1, 2, or 3. Okay, so I just need to program for if 1, if 2, right? If it's not one of these, then it will be else. Okay, all right. However, for some of you, if you have not programmed this method on checking whether it should be 1, 2, and 3, all right, you may have to select elif weapon is equals to 3, okay, to make sure that it is really selected as 3. And here I'm going to return stone. Okay, so a little bit of a sidetrack over here, as I forgot to mention earlier. When we use the word return in a function definition, we are essentially getting the function to get this piece of information out of the function and immediately stop the function, right? It wouldn't go on to the next line. Okay, let me just do a simple demonstration on this. Okay, let's say I just change all of this away. So I want to define check past. And let me see, I want to have a list. Let's say a number list. Okay, so this is me trying to define a function that check if someone has failed the exam, right? So inside this list for for num in num list, okay, if num is less than or less than 40, all right, I am just going to say print someone failed. Whole class failed. Okay, that means if someone actually failed, right, the whole class will fail, right, and then I'll break. All right, I immediately stop checking. Okay, as this as soon as one of them fail, all right, I would not break. I will just return. All right, I will just immediately stop the whole thing. Okay, all right, or else I will just leave it like this. Okay, and let me just try to generate a random list. Okay, let's say let's do an import random. Okay, let's create a list of 10 people for I in range 10. Okay, let's do oh, I need a list also. Score list, empty dictionary, sorry, empty list. Okay, score underscore list dot append random dot rand in. Okay, let's random from 0 all the way to 100. Okay, so these 10 people will have score randomly from 0 to 100. Okay, and once we have this list ready, I am going to pass it into my check passed. Okay, and I'm going to say score underscore list. Okay, so let's say if no one failed, then I would print, yay, everyone passed. Okay, so let me do this, right? And to double confirm that really someone has failed, we can also print out the score list just to check ourselves, right? Okay, so the first list, 82, 62, 56, everyone passed. Wow, yay, right? I can actually print it, okay? Because when I check through, no one has failed, right? However, if I go through another one, now, 88, 74, 105, 95, 61, 15. The moment someone has failed, right, this function stop, right? Because I said I print someone failed and I return, okay? Even if I don't return with any value, right, the moment the return statement is being called, okay, the function will stop, right? Someone failed, whole class failed, right? See how it comes out of the function and it will not print this if statement, okay? By right, this if statement should print at the end of the for loop. But because I have a return statement over here, the function has stopped, all right? So no, it will not go to the extent that it will print, yay, everyone pass, okay? All right, sorry for the quick detour. I'm just gonna go back to my scissors, paper, stone, all right? Excuse me, sorry. All right, so I have this weapon check ready, okay? Now when I run my code, okay, if I were to select a weapon, let's say I select 2, okay, now it will properly print the weapon that I've chosen, right? So I've chosen paper, the computer chosen stone, right? So player wins the round. Player score 1, computer score 0. All right, it's nice, okay? And if you want to introduce a bit of spacing in this printing over here, because now everyone is like everything is clumped together, it may not be the nicest thing to actually look at, right? You can just do a very simple print empty bracket over here, right? Then you will introduce an spacing. Ta-da! See, there is a spacing. Oops, there is a spacing over here. Okay, so you can just introduce an empty print on the places where you want to have their spaces in between the lines. All right. Okay, now I noticed that this may be a bit fast, so I'm just going to slow down and take a look at the chat and see what's going on. When do we use 1 equals and when do we use double equals? Okay, let's go through this. When we are using 1 equal sign, this is what we call an assignment operator. Okay, it is used to assign a value to something. Okay, and usually it is used in conjunction with variables, right? I set a score to 0, right? This is me assigning the score, assigning the value of 0 to the variable called score. All right, usually I don't want to say this as score equals to 0. All right, whenever I see a line like this, I try to read it in a way that I assign a value of 0 to score. Okay, so that you guys are not confused. Okay, and when you see double equals, this is your relational operator, right? That means you are trying to check for equality. Okay, you are trying to check for whether the thing on the left is equals to the thing on the right. Okay, so when I say score is equals to 0, now I am not trying to assign the value of 0 to score. What is going on over here is I am going to get the score, right? And check whether is it equals to 0 or not. Okay, so this will only give me two possible answers. Okay, this will either be true or false. Okay, and if you realize this returns a value because it returns true or false. However, the assignment operator does not return a value. Okay, it simply assign the value to the variable and that's it. Okay, now is it always a variable that we are using assignment operator? Not exactly. If you remember, we can change a certain list element by using the assignment operator as well. Right, remember? We use this assignment operator to change the value of a certain element in the list. Same for my dictionary. Excuse me. Okay, maybe we do the world. Okay, so assignment operators are not always used in conjunction with variables, but you see it very often with variables. Okay. Okay, cool. All right. So everyone have any problem with scissors, paper, stone? Okay. If not, we are going to move on to our next small project today, which is Hangman. Okay, we're gonna build a very simple Hangman game on the terminal. All right, and before we do that, I will actually paste a link for you guys to copy the constants, right? So I've actually created a paste bin link over here that contains some of the variables of the Hangman that we're gonna use, all right? So for those, I believe most of you have actually done Hangman, right? So Hangman is a game that allows you to guess a letter, and every time you guess a letter, you're supposed to try to guess the word as well, right? And when you guess the wrong letter, you will get a new body part being hang on the whatever it's called, right? So at this point, your head is being hanged, right? When you get the first wrong letter, second wrong letter, you show your left or right hand, right? Then the other hand, then your legs, and then when you see the full body being hanged, right, this is game over, right? So you're no longer able to make any guess, right? So in this link, there will also be other words that we can use to use as our hangman word for guessing, right? So I'm just going to paste this link in the Zoom chat for everyone. Is it called a hanger? Okay, so you can actually paste bin gallow. Oh, cool. Learn something new from you guys every day. All right. Cool stuff. So when you paste this link, you should be able to see all these constant variables, all right? I want you guys to copy the entire thing, all right, simply by using Control A or Command A. Oh, it's actually going to copy the entire website. Oops. That's bad. I just want this. I think you can do row like this. Oh, then you can copy the whole thing, copy it, and then paste it here. All right, we are going to do this. Well, yeah, you can hold and drag your mouse as well, but I'm a bit lazy. I want to copy everything. All right, and you should be able to see something like this. Okay. Now notice how all the variables are named with capital letters. Okay, this is what we meant by constant variable. You are not supposed to change this variable, all right, at any time. Okay, we have animals over here, we have countries, we have feelings, we have shapes, and we have sports. The easiest difficulty is actually animals, all right? The rest is actually pretty hard. So we're gonna create a program based on animals first. All right, now as this project is going to be a bit on the, is a bit time consuming. So we're gonna take a quick break right now. We will come back at 4:57. Okay, time now is 4:52. Let's take a quick break. And when we come back, we are gonna continue on this Hangman project. Okay. Okay. Let's see. Ascii Art generator. Okay, cool. All right. So I'm gonna continue. Let's build our Hangman game. Okay, so usually when we try to build something, we will want to come out with a flowchart of what do we want to do with this program, right? So let's just do a simple flowchart for this. All right, so in our program, first thing that we want to do is we want to have an intro, right? Of course, when you play a game, you want to introduce to your users, okay, what are the things that you're going to do and what is the name of this game, right? And after that, you want to make a guess. Okay, so guess a letter. Okay, and after you guess a letter, you need to then check if it's correct. Right, so after you guess a letter, you want to check against the magic word that you have just, oops, sorry, I'm very bad at drawing lines. So after you make a guess, you want to check against the magic word to see if it's the correct letter, right? If it is, okay, so if yes, okay, I will actually try to draw it like this, so that it's more like an if statement, right? So this is so ugly. Let me just try to erase this. And draw it out. Okay, check if it is correct. Okay, if it is, then we will show it on the character, right? So let's say, for example, at the starting, you have 5 or 4 characters, right? And when you guess the correct character, you need to actually show it on the correct position, right? So we need to show it, okay? However, if it's false, you will need to increase your hangman count, right? And then show it on the list of wrong letters that I've shown, okay? So this will increase the wrong guess list. Okay, sorry. False. You will also increase the wrong guess. Okay, and then after that, you will need to check if the wrong guess is more than 5, right? So if wrong is more than 5, this will be game over, right? Game over. Okay, as you can see, I'm not very good at drawing flowcharts, but I'm trying. Game over. Okay, however, if this is true and it shows, right, we need to go back to guessing a letter again. Okay, let me just draw it like this. All right. Okay, if you make a wrong guess and your guess is not more than 5 yet, right, then you will also go back to guess the letter. All right. So technically speaking, you have 2 possible ways of going back to guessing a letter, right? The first way is when you guess it correct and it shows on the screen, and then you guess another letter. However, if you guess wrongly, all right, I will uptick the number of wrong letters that you have made, okay? And to check if it's more than 5 yet. If it is more than 5, I will need to show you game over. However, if it's not more than 5 yet, I will get you to guess another letter. All right, so let's do it step by step, okay? This idea of writing a flowchart is also an idea of what we call the decomposition. All right, we are trying to break down a huge program into small parts where we can operate slowly. Okay, so let's say, for example, this is 1 function, this is 2 function, this is like a 3rd function, 4th function, and so forth, right? So when I create a function for all of this, I would have created the whole program. Okay, so let's start with the first function, which is to create an intro. Now, let's create an intro. Let's go back to our REPL. Okay, I'm not sure if you guys have explored these Ascii fonts before, right? So back in my time, right, when we read like game FAQ, right, or game guides, usually we'll start with some font like this, which is pretty cool. Okay, so we are gonna use this font to introduce our Hangman game, right? So Hangman. Okay, I'm gonna paste this link to you guys so that you guys can try this out as well. To everyone. Okay, it's called Ascii Art. So you can use a lot of different fonts, right? Star Wars. Wow, cool. Okay, electronic. Okay, and AMC Tube. Okay, up to you to decide which one you want. Okay, so I am gonna select Ascii New Roman. Actually no, better not. Contessa. Okay. Not really nice. I feel like Star Wars is still one of the better ones. Maybe Elite. Okay, this kind of looks like Hangman. Okay, I'm gonna do this, right? So what I'm gonna do is actually to just copy this whole thing, all right? Just copy, and then go back to our REPL. We're gonna paste it as our intro function. Okay, let's define a new function called intro. Okay, and this function is supposed to print, all right, a multi-line quote, right? Remember, if you want to print something that is huge, right, we probably need a multi-line, right? So we just do triple quotation mark, 1, 2, 3, right? Make sure it's triple. Okay, ending also must triple, all right, and paste the stuff that we have just copied. Oh, I didn't paste the whole thing. Okay, let me just, how do I paste this whole thing? Yes, like this. Copy, paste. All right. Now, of course, it looks like a bunch of gibberish right here. Okay. To make sure that it is really working, we can just call the function to see. It does look like gibberish. Okay, maybe not the best font. Get the edge. Wow. 3D. Okay, none of them actually look nice. Stronger than all. This. Okay, let's try this. Okay, run it. Oh my god. Okay, this looks normal. Now, it may not look exactly the way it is over here because I got a feeling that it's because our screen estate is actually smaller here. Oh yeah, see? When it's bigger, it actually makes more sense. Okay. All right, Ken, I'll just leave it like this then. Because it looks better when it has more screen estate. Okay, so once we have done this, we need to give the instructions, right? The title alone is not going to be enough. Okay, so let's give some instructions to our user, right? So instructions. Okay, so guess a letter that belongs to the magic word. Okay, if you guessed it correct, the correct letter will show on the screen. Okay, right? If you guessed it wrong, you will be punished. Okay, no lah. You will get a body part hanged on the gallows, right? Okay, so this is the instructions, right? So we run it. Okay, good. We have the instructions. So we know that we have the intro ready, right? As long as we call this intro function, all right, we are definitely going to get this message. All right, and in the future, if you want to tweak this intro for a bit, you can just refer to this function without interrupting your main code. Okay, so that's one function done. Okay, the next function is to actually get a word, right? We actually missed out one part on the flowchart, right? Before we guess the letter, we must first decide what is the magic word. Okay, so I am going to define a new function called get magic word. Okay, so which is the word that we're gonna get? Now, to make things simpler, all right, I am actually going to use the animals category. Okay, so we're gonna pass in the animals, and as you can see, this is actually an entire string, right? So if we're gonna change a string to become a list of singular characters, okay, we can use the list method. Okay, however, if you want to separate them into individual characters, let's say, for example, ant, baboon, badger, and so on, we need to use the split method, right? The string method that, oh, sorry, the split method that belongs to strings, right? And after that, after we split it, we actually need to randomly select one, okay? So let's go through one by one, okay? Let's do the split first. So this magic word is going to get a category, all right? And then first thing first, you're gonna print the category, right? Because you want to know what are you actually guessing, right? Print category. Okay, sorry, maybe just do an F string that the genre is category. Oops, my full stop should be inside. Okay, so the genre is category, all right? And then we want to select one of the words at random. Okay, so how do we do that? First thing first, we need to split it. Okay, how do we split again? We indicate the list that we want to split, sorry, the string that we want to split, which is category, dot split, and then we execute the method. All right, if you do not have any argument inside the split method, all right, that means it will just split based on the spaces, right? All these spaces will be split. Okay, if you have indicated any delimiter such as a full stop or a comma, then it will split according to this particular delimiter. All right, so we are just going to split it based on the spaces to get the different elements over here. Now, after we split it, okay, if I were to print this for you, okay, let's just do it one step at a time, right? So that you see the progression of this. Okay, I'm not gonna do intro first. Let's just print magic word to make sure that we are on the right track. Animals. Okay, get magic word is not defined. Oh, okay, now I made a mistake over here. Can you see that my define actually has an indentation? All right, this is me trying to tell the computer that, oh, I will only define this function when I call the intro function. Okay, so I made a mistake over here. Okay, I'm so sorry. Let's shift tab this, all right? Make sure that this definition of a function is its own definition, not within another definition. Okay, so let's run this. And then you will see that the genre is ant. Oh, it's not actually printing the name. It's actually printing the value that's holding it. So this is wrong, right? So we actually don't need this. Okay, and let's do this again. Split. All right, so I have ant, baboon, stuff, and all split up. Now I'll have to select one of the word randomly. Okay, so far we have learned about random.randIn. Today we're going to do another one of the function that's inside random. It's called random.choice. Okay, so let's just import random as a module first. Okay, let's do it at the very top. Import random. Okay, and once we have imported random, we need to use one of its function. All right, so instead of printing category splits, I want you to print me the random dot choice, all right, with a bracket wrapping the category split. Okay, now make sure your brackets are make sure your brackets are closed properly, right? Now, if I want to make this a bit simpler, okay, we can actually split it in this two particular manner. Okay, so I can just call it the word list first. Okay, and then I will random.choice the word list instead. Okay, this will make it a bit clearer. Okay, easier to read. All right, sometimes one-liners are not always the best code because it's very hard to read. Okay, so in this case, I'm actually splitting up the category first and save it into a list. Save it into a variable. All right, now this is a list. And with this list, I will print a random choice that's within it. Okay, now let's assign it to call it the magic word. Okay, and we can then print the magic word. Okay, Rhino. cobra, and so on. Okay, this is how you know that your function is working, right? It is giving you a randomly selected choice of the category animals, all right? And it depends on whether you want to print it or not, right? When you're playing a game of Hangman, it doesn't make sense if you print the answer straight off, right? So what I want to do is I will just return this magic word, and I'll probably save it in a variable that I'm not going to show to my user anytime soon. Okay, so let's just keep it like this. All right. So at this point, let's see if all of you are okay. Can you pause for a while? I need to catch up. Can. All right. I can pause for a while at this point. Okay. And also, there will be recording of this video, so don't worry too much. You can actually pause it and slow it down when you play the recorded video. Okay, let me just try to rewind a bit. Okay, we have done the introduction function, right? And now we are trying to get the magic word that we're gonna guess, right? So by getting this magic word, we must first pass in the category, which we have a lot up there, right? We have animals and countries and stuff. So I'm just gonna pass in animal later on. And when we are passed in a string of different characters, okay, we have two ways to change it into a list. Okay, the first way is by doing a list. But if you use this method, if you remember correctly, okay, this is going to provide you a list that contains of all the individual characters. All right, so this is not what we want when we want to get the individual words instead, not the individual characters, right? So if we want to do it the other way around, the other method to make strings into a list is by doing your split. Okay, so we have, let's say maybe char man der dot split. Okay, when you split it in this manner, you are going to get a list of char man and der, right? Because we are splitting it based on the spaces in between. Okay, when you don't indicate anything inside the split function, the split method, you will split it by its empty spaces. Okay, understand? All right. So with that said, all right, after we have the list, we use random.choice to select a random element that's inside the list. Okay, so this is also an idea of abstraction, right? What do I mean by this? When I use the choice function that belongs to the random module, do I need to care about how it actually helps me in selecting it? Right? Do I need to know that, oh, they actually do it by lottery manner, or they generate a random seed and I get a random element out of the list, right? I don't need to know all that. Okay, so this is an idea of abstraction. I just need to run the function and I know that this function would definitely give me a random element, and that's it, right? So that is the point. That is the level of abstraction that we want with our programs, right? When we want people to use our function or our program, we don't need them to worry about the nitty-gritty back-end stuff. Okay, we don't need them to worry about, oh, would that particular variable work in that particular manner? Not really. Okay, but if you're interested, you can feel free to jump in and have a look. Okay, now at the end of the day, once we have selected the magic word, I want you to return it back to me. Okay, because we are maybe going to save it in a variable or something, right, to compare against the guess. All right, so at this point we have gotten our word. The next thing to do is to get a guess from our user, right? So let's just call this define get guess. All right, so we're gonna get a guess. And when we get a guess, we are going to get the user to input, right? So maybe let's call this guess is input, all right? Please guess a letter. Okay, you can do it this way. Okay. Then if you want to make sure that the guess is a singular alphabet, all right, you can use some checks that we have done before, right? So while guess, the length of guess is not equals to 1. All right, that means if you typed in more than one letter, I would want to ask you again. All right, I do this. Okay, I want you to guess again. Now, obviously, having a singular letter is not the only condition where we want the user to guess again. All right, let's say, for example, what if they try to be cheeky and guess a letter instead? A letter is not a letter, sorry, not a letter, a number instead. Okay, so a number is not a letter, right? It doesn't count as a letter, right? There is no numbers in an animal name, right? So we want to check whether the character that is being input by our user is entirely made up of alphabets or not, right? And we have gotten the method that is used for this, right? To check whether all of them are alphabets, right? So we have talked about this 2 days back. This is guess dot is alpha, like this. All right, so this will return true if the entire guess string is made up of alphabet. All right, so we want it to be not alpha. Now, why is that so? Because as long as it is not an alphabet, all right, I want you to guess again. Okay, and not an alphabet is not the only condition, right? As long as you're not you're not an alphabet. Oh, actually I should use or, right? Or your guess is actually more than one, then you would need to guess again. Okay, so if you manage to meet, okay, wait a minute. Let me just think this through. This needs to be an n. Okay, now why is it needs to be an n? All right, it needs to check whether you are an alphabet or not, and also whether you have one character or not. Okay, so let's say, for example, if you put a singular character, all right, which is a number 8, okay, this will pass this test, all right, but it would fail this test, right? So if it fails this, I need you to input again, all right? So if you actually give me a proper number, let's say, a proper letter, let's say like G, okay, so first thing first, guess is equals to 1, so this will be false. And then your guess alpha, this will also be false. This will not activate the while loop. You don't have to input again. Okay? All right. So this is the condition, the complex condition that you need to write to make sure that the input is definitely made up of one character, all right, and it is an alphabet. Okay, someone raised a question. Let's have a look. Okay, we cannot do is numeric instead because what happens if the user key in a symbol instead? All right, if I use is alpha, I would definitely be able to tell whether is it an alphabet or not. Any other thing that is not an alphabet, be it a number or be it a symbol, I would also not accept it. Okay. All right, so at this point, this is fine, right? I will be able to get the guess. All right, but guessing the guess is not enough. We still need to check against now. Is it a correct guess or is it a wrong guess? Or is it a guess that have been guessed before, right? So we need to have two different lists. One list for the correct guess and another list for the wrong guess. All right, so this is where it gets a bit complicated, but bear with me, all right? We are going to check if the guess is in already guessed. Okay, now already guessed is a variable that we need to pass in, right? Because we need to check whether this guess has been guessed before, right? So I am actually going to pass in my already guessed as a parameter, right? That means when I execute this function, all right, this get guess, I need to pass in the list of alphabets that has already been guessed before. Okay, if it's inside, right, then I am actually going to print This alphabet has been guessed before. Okay. All right, and then I can do another elif to check if guess is in, all right, the magic word. Okay, so if guess is in the magic word, all right, I would need to change something, right? So let's say, for example, my magic word is rhino. Okay, I am going to have a correct guess list that is consists of 5 different characters. Okay, sorry, there's not enough space there, so it's not very clearly illustrated. So let's say like this: Ra, H, I, N, O. Okay, basically it is a list. Now, why do we need it to be a list? Because not only list, a list is mutable, right? At this point, they are all underscore. But if I made a correct guess of, let's say, H, I want this to be H instead of an underscore. All right. So just to give you a rough idea of what am I going to do, okay? At the end of the day, I would have magic word will be excuse me. I would get a magic word that is based on animals, right? So this is gonna give me a word. Okay, it's gonna pass in, it's gonna give me a word. And once I have this word, I will be able to generate a list of correct guess that is made up of a lot of different underscore, okay, multiplied by the length of magic word. What do I mean by this? Okay, if my magic word is rhino, then I have 5 underscores. All right. However, if my magic word is peacock, then I will have a list of 1, 2, 3, 4, 5, 6, 7 underscores. Okay, that is what it means. Okay, I can do something like this. Okay, it is very similar to the string duplication. All right. And last but not least, I will also have a wrong guess that is an empty list. Okay, because currently no wrong guesses has been recorded, right? If there is a wrong guess, I will need to append it inside here. Okay, so what I'm going to do over here is I will just say elif guess in magic word for I excuse me, for I in range of the length of the magic word, right? Why do I need to use I? Because I need to change a specific index number in the correct guess list, right? So for I in range number, if guess is exactly the same as the magic word at this particular position, all right, at the I position, okay, I am going to set the correct guess at this position to be guess. All right. Now, this may look a bit confusing. I am going to illustrate this out here. Okay, let's say, for example, I have rhino. And I have correct guess 1, 2, 3, 4, 5. Okay, how do I know if I should change this to H? Okay, I do not know. So I need to get the computer to check through one by one, right? How do we get a computer to check through one by one? We use a for loop. Okay, and once the for loop is activated, okay, once we are going through one by one, we can use an if statement to check if the letter that we have guessed is the exactly same letter as the one that is being referred to right now. Okay, your square bracket I. If it is, let's say for example, if it's H, all right, that means my magic word square bracket 1 is equals to guess, right? So in this manner, at this position, of my correct guess, okay, this is also index position 1, right? Because it corresponds exactly to the magic word, right? So I would set my correct guess at this I position to be assigned a value of guess, right? So the next time when you see my correct guess, instead of 5 underscores, it will be underscore H underscore underscore underscore. Okay? All right. Now, once this is done, we would then, sorry, we would then do an else, all right? Because if the guess is not in the magic word, okay, else, we will just do wrong guess, sorry, wrong underscore guess dot append guess. That means this letter would have entered the wrong guess list, okay? And how would this affect the game, okay? Remember, we have a hangman at the very top, okay? At the zeroth index, sorry, at the zeroth index, right? It is the picture of a hangman without any body parts, right? Now remember, this is a list, okay? Notice this is a list, okay? So we can actually use this list to our advantage, right? When there are 0 item in the wrong guess list, we would show this image, all right? So the next time when the wrong guess is increased by 1, we would show the next image, right? Because it is now the first index, all right? And so on. And you realize that the moment when we reaches the 5th mistake, it will be dead, right? So we are dead. Okay, so we're gonna print the hangman picture based on, oops, sorry. We are going to, sorry, print the hangman picture based on, right, the length of the wrong guesses. Does it make sense? Right? So when my wrong guesses only have 0 item, naturally I have not made any mistakes, right? But the moment this wrong guess increased by 1, this length function will now give us a value of 1, which is on the first index. All right. So I hope this makes sense to all of you, all right? Okay. So let's go back down. Okay, we have this wrong guess over here. All right, now let's see if this works. Okay, the next part is to actually try it out. Okay, I'm gonna have an intro, and I am going to have a get guess. Okay, let's just try it out to see if it actually works. Okay, all right, some problem. Already guess is not there. Okay, so let's go up and have a look. Okay, we have already guessed as a parameter, but when we run our get guess, we have forgotten to put in our parameter. Okay, sorry, the argument, right? So what is already guessed, right? How do we know what are the letters that have been guessed before? All right, obviously, when we have guessed a letter, all right, if it's wrong, it will be in the wrong guess list, right? If it's correct, it will be in the correct guess list, right? Remember, we have this assignment over here to assign the correct guesses in the correct guess. So when we pass in a list of both correct guess plus wrong guess, sorry, all right, this concatenation would give you a complete list of the letters that have been guessed before. Make sense? All right, so let me just print this out. Just guess a letter, let's say maybe G. All right, at least there's no error, but as you can see, there are no printing of any sorts of indication, right? So we actually need to print something, okay? We need to print the characters that's in the list, right? So let's say, for example, I need to print F, I need to print correct guesses is your currently it's a list. So how do we make it into a string? Right? We can use the join join method, right? So I can use this, comma, comma, dot join, correct, guess. Okay. And oh, need to end with a curly braces. Okay. So when we use the join method, we are trying to join the elements that's in the list together to form a singular string. All right, so let's see if this works. There is squiggly lines, so I am skeptical. Okay, so obviously because we are using double quotation marks here, double quotation mark here, and there's also double quotation mark inside the join. I'm just gonna use a single quotation mark inside the join then. Okay, and make sure there is a space because we need to join this underscore together with spaces in between, right? I want to see something like this: 1, 2, 3, 4, 5, instead of 1, 2, 3, 4, 5, right? Which I can't see anything, right? So we need to give in some spaces. Okay, and then same thing, I will also print the F for wrong guesses. Okay, wrong guesses, same thing, all right? Singular quotation mark with a space, and then we join the wrong guess list. Okay, we have a list of wrong guesses, and also we have a list of correct guesses, right? Okay, so now when I run it, okay, guess the letter. Let's say I put 8. Something is wrong. By right, it shouldn't take in my numbers, right? So let's take a look at our function again. While guess dot is alpha, is 8 an alphabet? No, right? Why would it take it in though? Interesting. Okay, let me do it again. Okay, this is A. Oh, actually one of it is correct. Wait a minute. Let me try to debug this. Is it because I forgot to have a parenthesis? But not will always resolve first. 8. Okay, I think I realized what's wrong. Here, because the length is actually not equals, it is actually equals to 1. So maybe it should be or. But if it's or, let me try or. Oh, it's actually using or. It shouldn't be an and. Okay. Made a mistake. I'm sorry, guys. So for this, all right, instead of and, we actually need to use or because, right, as long as the length of guess is not equals to 1 or it's not an alphabet, I will need to repeat it. Okay. All right. Cool. Sometimes you just have to try and error some things out. Okay, so this is working now. But the problem is it will only ask for a guess once, right? It didn't ask for it forever, right? So usually in a game, we would activate an infinite loop. Okay, so we are usually going to do this where we put the game loop, right? Not the intro, inside a while true. Okay, so that's it. Can you scroll up? Yes, I can scroll up a bit, I guess. But we need to move on also, right, Braden? Now, over here, after I've done my intro, okay, I will activate a for infinite loop that will keep trying to get the guess of my user, right, until the point where the game needs to declare a winner or a loser, right? So the next part over here is to determine whether have we got it correct or have we got it wrong. All right, so the next part is to check against the word. Okay, so every time I made a guess, all right, I will also need to show my hangman, right? So let's just print hangman at the index of our length of wrong guesses. Okay, and not only do we need to introduce, once we get the magic word, we actually need to print how many letters are we going to actually going to get our user to guess, right? So we need to say that, let's see, where do we put this in? Maybe you can put it inside the game loop, print guess an animal name with this many characters, the length of your magic word letters. Okay, so every time the loop is being run or being executed, there is this line over here that says guess an animal name with this amount of letters, right? Because currently we're using the animal category, right? So let's see. Okay, so I need to guess an animal name with 5 letters. So I will guess the letter H. All right, so it is correct. So it shows me this, L. Okay, when I get a wrong guess, my hangman would show the head. Okay, then P. Okay, P is also wrong. Now let me try to guess a letter that has already been guessed before, like let's say H. Right, it will show me that this alphabet has been guessed before. Okay, but my hangman does not proceed, right? It will still show me one arm only. Okay, let's do P. Okay, which has also been guessed before, right? So maybe A. Right, A is there. So, okay, what animal is this? Maybe an L. No, there is no L. Maybe it's not a whale. Oh, what animal could this be? Okay, is there an R? There is an R. Okay, let's get the chat to help. What? Wait, what is intro do again? Intro is a function that just show the introduction of the game. Let me just show you. This part over here, Jacob. This is the intro. Okay, it may not look the nicest. Right, so this part over here is the intro. Right, this top half part. Okay, this is the intro. Now, why do I want to put it inside a function? Because when I change the code, I don't need to go to the particular part where the intro is and change the intro directly. I can just change the function and it will change my intro directly. Okay. All right. Okay, so let's see. Let's complete this. I still don't know what animal is this. Okay, maybe an E. Okay, I think I'm dead soon. All right, maybe a P. Okay, P has been guessed before. Okay, I. All right, I'm dead. All right, but now the problem with this program is this, right? At the end of the program, when you see a hangman, you should show game over, right? You should not allow your user to actually key in any more letters, right? So at this point, I can still key in letters, right? Index out of range because I can no longer refer to any of the hangman images, right? So I don't want this to happen. So we need to program the conditions to end the loop accordingly. Shark. Yeah, it should be shark. Yes. Thanks. Okay, I'm bad at this. All right. So now let's program a condition to end the program, right? So there are two conditions to end the program. One is where you have successfully guessed all the letters that is in the magic word, right? And the second condition is where you actually fail to guess it, right? You made some mistakes. You made 5 mistakes, and the moment all 5 parts of the hangman has been shown, you will need to stop the loop. Okay, remember to stop a loop, we need to use the break statement, right? So let's do this. So we can do, okay, we have definition of this. All right, the next part is to do if, all right, if your dot join correct guess is equals to your magic word. Okay, so this is me trying to check when all of your characters in the correct guess join together, all right, are they the same as your magic word? Okay, if they're the same, that means you have managed to guess all of the letters correctly, right? So I'm just going to print congratulations. You have guessed the word correctly before being hanged. The word is, okay, let's say for example you want to show the computer the user the word, right, to double confirm. Okay, you will need to use your F strings. Okay, now however, if this is not the case, right, elif, let's say for example your hangman has been shown fully, let's say if elif your length of wrong guesses is equals to 5, it will print, okay, F strings, boo hoo, you have been hanged, right? The magic word is magic word. Okay, so technically speaking, every time when you have made a guess, you will need to do this check over here. Okay, and if you want to do this in a function manner, you can also do that. All right, I'm going to show you later on how to do this, right? So let's say we play this. Okay, guess an animal name with 6 letters. 6. Okay, B. Okay, there's no B. All right, so maybe P. No P. Wow. E. Okay. Okay, can. We try, all right? E. No E. Anyone else want to give a guess? All right, A. Oh, there is an A. Okay, what could this be? C. All right, C. Okay, let's see. No C. Oh no, one more answer than I did. All right, S patient. We need to make this decision. I've been hanged. It's a lizard. Oh no. Okay, we failed. All right, so basically, this is the hangman game. Okay, of course, you can make this a bit harder by selecting different categories. Let's say, for example, sports, shapes. These have other higher difficulty words, right? Now, remember what I mentioned about making this even easier over here by putting this inside a function. All right, let me demonstrate how should you do that. Okay, so let's say for example here I say if join correct guess is equals to magic word, I will say congratulations and stuff. I'm just going to define all of this under a definition called game and check. Okay, and then of course I need to use the correct indentation. Okay, now the problem here is when you do this kind of a function definition, right? Take note of what are the variables that you need. Okay, in this case, I need to put in my correct guess, I need to put in my magic word, and I need to put in my wrong guess as well, right? So I would need to do correct guess. Actually, I don't need, technically speaking, I don't really need to, because these are global variables, all right? These functions can access to them easily. So let me just try to do it without. Okay, let me just show you. Okay, game and check. Okay, let me just take a look at the chat, by the way. It didn't show the magic word though. You didn't use the F string, Jack. Make sure to put an F in front of the quotation mark. Okay, so let's say, for example, I'm gonna stop this and run again. Okay. Okay, Hangman. Okay, a letter, 6 letter. Is it lizard again? No, it's not lizard this time. Okay, start with B. Oh, no. E? Oh, oh, R? Oh, okay. It's not beaver. Any help here? L? Nope. It's not beaver. If I guess E, it would have appeared here, right? By right. It's not a beaver, guys. It's definitely not a beaver. Oh, badger. Yes, yes, yes. Badger would be more appropriate. Yes. Ta-da! Yes, correct word, badger. Thanks, Jack. All right, so yes, it's the badger, right? So it will say, congratulations, you have guessed the word correctly before being hanged. The word is badger. All right, now the problem is we have forgotten something again, right? I didn't break, right? So I can still make a guess. Oh no. Okay, so we need to actually break this. So how do we introduce the break? When do we actually introduce the break even? Okay, this is the tough part. Right, we can't just write break over here. Okay. The ideal case for this is to actually, let's see. Ideally, it would be better if okay, can. I will also return true over here and also return, return true over here. And if it's not, then it will return false. Okay, so what am I going to do over here is I'm going to make this game end check a function that is either going to return true or false. Okay, why is that so? With that, I can then set a if condition, right, to say whether to break or not. Okay, the moment if it reaches one of these two game ending, right, it will return true, right? If it returns true, this if condition is going to resolve and then it will break the game. All right, it will break the game loop. However, if your function, right, always returns false, the if statement will be skipped. Okay, by default, the function game end check will return false. All right, only when it reaches a stage where your correct guess is equals to the magic word or your wrong guess is equals to 5, you will return true, which will then break the game. Okay, let's try this out. All right, theoretically, it should work. 5 letters. Okay, G. G is not in. Okay, I'm just gonna anyhow do this because I just want to see the ending. All right, boohoo, you have been hanged. See, it has been cleared properly, right? The word is author. All right, so the time now is 5:51. I'm gonna stop here a bit to take in questions, and if any of you need me to scroll up, Just let me know where I should stop. Okay. Usually when I define game end check and I'm using these correct guesses, I actually need to pass in the parameter like this. This is the correct method. Okay. I should actually show you guys the correct method. I shouldn't be lazy on this. All right. I should actually pass in these 3 variables because we need the function to use these 3 variables, right? So what I do is when I call the function, I need to pass in the 3 parameters corresponding, pass in the 3 arguments corresponding to the 3 parameters over here. Correct guess, wrong guess, and magic underscore word. So correct guess, wrong guess, and then magic word. Okay, when I run this again, right, it would still work. I should guess it correct. L, oh no, P. Okay, see, it will still work. Okay, it's a good practice to pass in the parameters that you need. All right, don't assume all of them would be global parameters because when you import this program onto another, let's say if you want to export this as a package, all right, it is better to indicate all your parameters correctly, okay, or else you will have an error. Okay, what do I mean by exporting a package? I will show you later on what do I mean. Okay, for now, let me just take a slow down and take a look at the chat. Can you scroll to the game end check later? Can. Let me just scroll it over here now. Okay. Hangman is actually a pretty interesting game for beginners because it's not the easiest to understand. Yeah, I actually struggle a bit when I'm doing this practice back then. All right, so it's perfectly fine if you're feeling a bit confused. All right, just try to follow along for now. Right, try to read the code again, and if you have the free time, just erase everything and write from 0 to the finishing of the code. Right, just start from scratch again. Okay, that's how I usually practice my programming. Right, I just look at some other people's code, and I'm not trying to memorize it, but I try to understand what's going on, and I just erase everything and try to build everything from what I understand or from my memory. Okay, because sometimes you can't just learn how to program by learning in school, right? It's kind of like us trying to eat sushi, right? We don't learn how to eat sushi in school, right? So when we have been to a Japanese restaurant, we see how other people eat sushi, and then we just follow along, right? Sometimes it's just like that, right? You need to look at other people's code and try to understand how it actually works. Yeah. Okay. Yep. Attribute error. String object has no alpha. Is alpha. Check your spelling, Verinda. Is alpha. It's not is alpha. Ron, you will get the recorded video at the end of the day. It will be posted onto the Build on ASEAN website. Okay, if you refer to the Build on ASEAN 2021 website, you will be able to see that the links that were supposed to be used to register for the course will now be a link for you to click onto it and watch a YouTube video of me presenting. Yeah, I can actually show you right now on the internet while I'm sharing screen. But it will actually disturb the others who are looking at it. So when you go to a Build on ASEAN 2021, when you scroll down, besides seeing my handsome face, you will also be able to click on watch recording, right? So you have your day 1, day 2, day 3, and day 4 should be ready by the end of today, right? Before tomorrow's class, which is going to be handled by Mr. Eric Tai. You guys will be able to see him at 7 p.m. tomorrow. But before that, I'm going to explain about cloud, all right? So don't worry too much about that. Okay, so I'm going to put this code here for you guys. Of course, I will also copy the link for you guys if you want to have a look at the code. Mark Russell asks, what? Okay, trace back. Okay, Braden, make sure your magic word is actually a word. It's written as a string. Okay, make sure it's written as a string. It's not a function. Okay, Mark, just now when I did not put in any parameter, it will still work because the correct underscore guess, the magic word, and the wrong guess, they are all my global variable. Okay, that means they are still able to refer to the variables that are readily available in the global environment. Okay, but it is actually a best practice to include the variables that you need as parameters. Yeah. Okay, by the way, sorry guys, let me just paste the link over here again. Okay, if you want to have a look at my Hangman code, okay, do feel free to click on the Replit link and refer to it. Okay, what is the function of len? Len is a function that returns the number of elements in a list, all right, or a string, or a number of keys in a dictionary. Okay, it is short for length. Okay, len is actually a short for length. Okay, it checks for the number of elements in the particular iterable. Okay, let's say your list, your string, your dictionaries, right? These are iterables, your sets. So if I give you another example, string like this, if you use a length function over it, this is going to return you 6 because there are 6 characters inside, right? So if you use a length over a list like this, okay, this will give you 3 because there are 3 elements inside the list. All right. When I do this underscore multiply by the length of the magic word, I am trying to create as many underscore characters inside a list as the number of characters inside the magic word being selected. What is the function of triple quotation marks, Roger? So triple quotation mark allows you to write things in a multiple line manner without you having to use \n to introduce new spaces and all. Okay, so to do a simple demonstration on this, I will use the Python Live Programmer. So normally, when you do print, you can only do one line like this, or you can do multiple lines like this, right? So let's say, for example, you don't want to have multiple print function, but you also want to, at the same time, print multiple lines of quotation, right? So you can do a triple quotation mark, and then you do hello world. This is your first line. Hello world 2. All right, hello world 3. Okay, and then you end with a triple quotation mark. All right, and then you'll be able to see your multi-line code like this. Okay, and also the beauty of triple line code is any spaces that you introduce inside the triple line code, sorry, the multi-line quotation, all right, it will be reflected exactly like that on the screen. Okay, you don't have to introduce your \n's. All right, this is usually only useful when you're trying to type multiple lines of, yes, as Eric has mentioned, multi-line strings, right? You're trying to do a print or actually multiple lines of string like this. And it's useful when we are using it in our introduction because our introduction is actually pretty long, right? If I were to do every single line one by one, there'll be a lot of different print statements, right? So when you're gonna do, when you're gonna have strings in multiple lines, you will just use a triple quotation mark for multi-line strings. Okay. All right, so time is 6 p.m. We just take a quick break right now, right? We come back at 6:07. I am gonna do one more very simple project called a palindrome project with all of you, okay? And then we are going to move on to introduction to cloud, and we will call it a day for today at the end of the cloud introduction, okay? So yeah, let's take a 5 minutes breaks, right? I am going to leave my screen here. Okay, if you want to change the category, we just change the magic word animals to sports type thing, right? Okay, so some of you actually asked about how do we get the random topic, right? Oops, why is it blacked out? Okay, so if you realize on the get magic word function, right, we need to pass in the category, right? This is where we decide which category do you want, right? So at this point, when I get my magic word, I put in my animals. Okay, if you want to put in other things such as shapes or spots or even fillings, then you would just change this over here to, let's say, maybe fillings, right? But of course, if you change this to fillings, then your description needs to change a bit, right? Because currently I'm guessing, I'm trying to get my user to guess an animal name, right? If you change to fillings, then maybe guess a filling or something, right? So you need to change accordingly. For starters, I think animals is a bit more friendly. If you use the other categories, it may be a bit too difficult, especially shapes. Shapes is crazy. There are a lot that I can't even pronounce properly. Okay. Yeah. All right. Um, like I said, I'm just gonna go through one or maybe two more project, maybe just one, very short one, right? Not gonna be as long as this. Okay, and we are going to then move on to introduction to cloud. Okay, so the next project that I'm going to do is, let's say, a palindrome. Okay, I'm gonna use the live tutor. Okay, so a palindrome, okay, is any word that can be spelled backwards, right? That and they would still be the same. Let's say, for example, civic. Okay, if you spell it backwards, it is still civic, right? So this is a palindrome. So how do you write? Oh, race car is also a palindrome. Yes, very good. Race car is also a palindrome. Okay, yes. So how do you taco cat? Okay, I'm sure these guys have played the exploding kittens before, right? Taco cat is also a palindrome. Yes, Anna is also a palindrome. Correct. Cool. Now, you guys know all these palindromic words, right? So now how do you actually program, all right, or write a code that can help you to check whether it's palindrome or not? All right. It can be as complicated as like maybe 5 or 6 lines, or it may be as short as just one line. Okay, let me just show you. Yes, YY is also a palindrome. Cool. Thanks, Braden. All right, so palindrome, let's define this function, right? Let's define a palindrome. And this palindrome requires a word. Okay, we need to pass in a word and then you need to perform a check, right? So back then, when I'm not so good, I'm actually still quite bad in programming, right? So I have a very peculiar way of solving this, right? So if you realize civic, let's say for example CIVIC, all right? If we were to check if it's a palindrome, that means the first and the last letter must be the same, right? Same for your second and the second last, and then the third and your third last, right? So if you realize this pattern, okay, let me just close the chat for a minute, okay? Your zeroth index must be the same as your, this is the first index, this is the second index, let's say for example, must be the same as your -1. All right, your 1 must be the same as -2, right? Your 2 must be the same as -3, and so on, right? So back then I was thinking that, oh, maybe if I can figure out a pattern to this, I may be able to write something out, right? Because if you realize the first index, which I will call I, and the second index, which I will call J, okay? If your I is equals to J, which is I equals to like negative of I plus 1, right? No, 0, plus 1, 1, negative of it is negative 1, right? So 1, 1 plus 1, 2, negative of it is negative 2, right? So if it can meet this kind of category, so if it meet this criteria, it should be a palindrome, right? So back then, this was my thinking. All right, so I will write something like this, okay? If word I, okay, of course we need to go through every single word, right? So for I in range of the length of the word, okay, if word at the ith position is exactly the same as the word at the negative I plus 1 position, all right, then it will be, let's say, return true. Okay, actually maybe I shouldn't return true because I need to progress to the next check. Okay, let's say I have a is palindrome. Okay, this is a variable that tells me that it is true, right? It is a palindrome. Okay, all right, else, okay, that means if one of them is not the same, all right, is palindrome is then equals to false, and then I would return is palindrome. Okay, at the end of this, I will also return is palindrome. Okay, why do I need to have two different returns? One is for when I fail it, right? I will need to immediately return, right? And then it will be false. Okay, and the second one would be true whenever the same is, sorry, it is equals, right? So based on whether true or false, I will print whether is it a palindrome or not. If palindrome, okay, let's say if palindrome, I will then print the what is palindrome. Okay, I can even pass in the word, right? The word. Then I will do else. Okay, and I'll just put in the word here. Okay, so what is the word? I can just do input. Give me a word. Okay, so there is an input over here. Let's say I put civic, submit. All right, give me a word civic. Why is it being printed? What if palindrome, the word is a palindrome? Else is not a palindrome. Okay, let me try this again. Civic, submit. Give me a word civic. That's weird. What is going on? Oh, maybe I didn't call it. Maybe I didn't call the check palindrome word. Okay, let's say palindrome word. Okay, I'm just gonna call the function like this. Civic again, submit. Okay, I don't know what's wrong with this, but I'm gonna try it on repo. Okay, let me just do a new repo. Copy, paste, run. The word civic. The word civic is a palindrome. Okay, so let's say give me a word. Let's say race car. Okay, race car is palindrome. And let's say something that's not palindrome. Let's say pokok. Pokok is not a palindrome. Okay, now there is actually a shorter way to doing this, and it actually involves slicing. And when I found out on Stacks Overflow, I am utterly defeated, right? So let's see how we can actually show if it's a palindrome, right? It is actually as easy as this: return word -1. Okay, right, as easy as this. All right, now what is happening over here is when you use the word to check against itself in a reverse manner, right? If your reverse word is the same as your initial word, that means it's a palindrome. Okay, so that's that, right? It will return true or false based on this condition over here. Okay, if it's the same, it will return true. However, if it's not the same, then this will return false, right? If it returns false, this will show it is not a palindrome. Okay, so this is as simple as that. Okay, now what is the purpose of me trying to show you this code? Is to tell you that yes, there are actually a lot of different ways to solve a very similar question, and sometimes we may take a bigger route to solving it. But at the end of the day, if we can reach the same solution, it is good enough, all right, for beginners, right, for now. Okay, we don't really have to care about the memory allocation. Is it the optimum code, right? At this point, just code away, right? As long as we can reach the same conclusion, it is fine, right? As long as it delivers, it's fine, okay? There is no absolute how do you say this? There is no absolute answer that is the best answer at this point. All right, there is a lot of different factors that comes into play. Okay, so don't be disheartened if you have a very long code instead of a very short one. That is actually it looks better, but it may not be better because in terms of readability, some people may not understand what is actually going on. Okay, so we have to take into consideration on readability as well, right? How easy it is to read your code. Okay, so yep, that's that. And time is 6:20. Maybe I should go into cloud right now. Okay, so let's just take a look at what is cloud before tomorrow's class about having to walk around the AWS management console. So let's see. So all of you here, all of you are here because this is an AWS training, right? So let's see. When do we use return? Okay, actually, let me answer this one. It's very important. When you want your function to actually give a value back, you will use return. All right. Quite. Let's say, for example, if okay, let me think of a better example for this. In this case, we are actually returning a value of whether true or false, right? Let's say if I don't have all of this, and I print palindrome. Let's give it a word civic. Okay, can you see that I can get the value true? This is because the value is being returned to me. There is a value that I can store somewhere. However, if I don't have this return, right, I print only. Okay, when I run this, you will see that when I try to print this function, it will show me none. Okay, none is also a data type that only have one value, which is none. Okay, it doesn't make sense. It's just saying that there is no value being passed back. Okay, there is no value here. When I'm trying to print no value, it is none. Okay, I hope it makes sense, right? So when you're trying to define, let's say, for example, an add function, add num1 and num2, right? So naturally, when you want to use this function, you want to return num1 plus num2, right? So that when your user use it, if they want to just print the add of 8 and 8, they are expecting a number of 16, all right? And not only because they can use it to print, they can eventually use this number for some other things like saving it into a variable and so on. Okay, so ask yourself this question: when you write the function, do you need the function to give you a value back? Okay, that may not sound like the perfect English, but yes, consider the fact that whether do you need a value out of the function or not. Okay, if you need something out of the function, then you write your return statement with the value. Okay, you can also write return without anything. Okay, now what does this do? Okay, if you just write a return without anything, you're just trying to tell the computer that you want this function to stop right here, right? It will serve like a break statement. Okay, and then the next few lines in the function will not be executed, right? It will just stop at return. Okay, it's short circuited. All right. Okay. Yep, that's return. Does hashtag compulsory to be typed in? When you are trying to explain a set of code to your fellow programmer, it is better to have hashtags so that, especially when you have a very long set of code, right? And you don't expect your fellow programmer or your users to actually read through one by one to understand what is going on. So we use these comments to describe what is the following following blocks of code are going to do. We usually use this as descriptions. Okay. Let me give you an example. Let's say I have the following code is for the movement of SAMS. Let's say I have a long side of code, and this is actually just me describing the movement of SAMS. All right, then the fellow programmer will understand this easier. Oh, okay, so this set of code is actually for SAMS, all right? And then maybe we have another one that says the following code describes the nature of the world, something like that, right? Just an example, right? May not actually be true in the video game industry, right? Because I've never been inside before, right? But these comments are used in this manner, right? Where you want to write a comment for your fellow programmers so that they understand what is the use of the following block of code. Yep. Okay, all right. If there are no more questions, let's go back to our cloud. Okay, so this training is actually made possible because of AWS, right? But who and what is AWS, right? So AWS stands for Amazon Web Services. Okay, all of us here know Amazon because we buy a lot of stuff from Amazon. I think I buy a lot of stuff from Amazon, right? I used to buy stuff during Cyber Monday, right? Black Friday, right? Christmas. Those are the peak seasons where a lot of good deals are available, right? Then we buy from Amazon. But Amazon App Web Services are actually a subsidiary of the Amazon company itself, right? So this is actually they are actually the provider of cloud services. Okay, so this word cloud always appear on the newspaper or when our IT club is giving a presentation, right? The cloud, right? The cloud. What is the cloud actually? Some people say that this term has been used since the American Army days, right? I know what is Amazon, but I don't use them. Oh, okay. All right. Oops, sorry. Let me just close that. Okay, so let's talk a bit about the cloud. Why are they called the cloud? There are actually a lot of different explanation, but for me, the explanation that makes sense is if you think of it like the real cloud itself, they're actually made up of a lot of different water droplets waiting to be changed into droplets and fall down, right, as rains, right? So instead of water droplets, I want you to imagine there are a lot of different computers somewhere else, right? So there are a lot of different computers. Okay, and these computers are freely available for us to rent. Okay, I use the word rent. Okay, so basically the idea is, right, the cloud is a huge cluster of computers, right? They have a lot of processing power that we can use some of it by paying some money, right? So we can rent part of this processing power. Now, why do we want to rent this processing power? Think about it this way. All of you should be quite familiar with your computers, right? So we have our CPU for the processing power. Okay, we also have GPU for graphics processing, right? Graphics processing, and we have our hard disk, SSD or maybe HDD for some of you for storage. And what else? Usually these are like the main components, right? You need your processing power, right? And oh, your RAMs, right? Your random access memories, okay? Maybe your 8 GB, your 16 GB, your 32 GB, and so forth, okay? Now, all this power for our computer, we can use this to achieve a lot of different great things, right? Like playing video games and coming out with a web app, all right? Creating your first website and stuff, right? But have you think about using this power to create a model that learns about artificial intelligence, right? Something that our computer may not be powerful enough to achieve, okay? And let's say, for example, you just want to do this very small project that requires a lot of power, like maybe some video editing, and you just need to do that for one project. Would you want to spend the amount of money to get all the different components, right? All the different computer parts to make up that one computer just for that one project? Chances are no, right? You don't want to do that because it will be a sunk cost if you're just going to do it for one project and that's it, right? Now, so that's where cloud come into play, right? Instead of us buying all the physical parts of these computers, we can rent some of this processing power, right, from different cloud service providers such as AWS or maybe even Google Cloud provider, Google Cloud, how do you call it, GCP, Google Cloud Platform, right? And then there's also Microsoft Azure and stuff, right? There are a lot of different cloud providers now out there right now. We can use part of the power and to achieve the things that we want, right? Achieve the tasks that we want to do, right? Such as your video editing, coming up with your own websites, and maybe coming up with your own video game, so to speak, okay? And one of the most common usage is actually storage. I'm sure most of you use Google Drive. Most of you would have used Dropbox, right? So these are actually storage space, right? It's like me carving out a part of my hard disk for you to use, right? So this Google Drive and Dropbox usually provide you like what, 30 gigabytes of memory or maybe 20 gigabytes. Okay, when you go out there and you're asked to buy one SSD and one HDD, do you think they will sell you 30 gigabytes? Chances are no, right? I think the smallest solid state drive out there is 128 gigabytes, right? So you don't really have to use all of this, right? So you just want a small portion of it. That's where cloud comes into play, right? You can just use pay a small amount of the money, and then we rent for these services. Okay, so that's cloud. What if the cloud is full? It is quite impossible for the cloud is full, but there is a chance that it is. So most of the cloud providers are rapidly increasing, right, in size. Okay, so I think Amazon recently purchased a data server in Africa or something, right? So you're gonna have more and more data centers out there to expand the cloud. Okay, so that it's very hard for it to be full. Okay, so that is a general idea of what cloud is, right? You can rent computing power at your own leisure. Okay, 64 gigabyte. Yes, when you're trying to train an artificial intelligence model, you may need more processing power, right? Your computer may not be able to support. You may need to have 64 gigabytes of RAM, for example. Okay, to do that, you need to either buy a new computer or you can just launch a virtual instance on the cloud. Okay, so that's cloud computing in a nutshell, right? And the next question is, why do we actually use cloud computer? All right. Let me just quickly go through some points over here. One of the important idea is because cloud is highly available. All right. So no matter where you go, all right, or who are you dealing with, or even what time is it at, okay, once your information is safe in the cloud, there is a very low chance that it will be gone. Okay, because if you notice how cloud works in a data center, right? Let's say this is data center. Okay, there are actually a few other data centers as well that they back up each and everyone's data. Okay, so imagine this, right? Once your information is in the cloud, it is being backed up like maybe 3 times. Okay, so if one of the data center actually failed, you will still have another one to support it. Okay, so that is the security of having an information in the cloud. Okay, and of course, this cloud information is highly encrypted. So if you have any secure information, all right, they are like private and confidential information, they are also secure in the cloud, right? But of course, right, the best practice is not to upload sensitive information onto the cloud, right? Let's say, for example, if this information is going to like cost a huge amount of fortune for yourself, or is it a very sensitive information, try not to upload it onto the cloud as well, right? No matter how secure that they mention it to be, there will be some form of risk involved as well. Okay. 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 Attendance sheet. There is no attendance sheet and there is no evaluation link. Right. It's perfectly fine. It's a free training, right? So you can just come and go. Right. Don't worry too much about it. Okay, so besides free, highly available, okay, it is also scalable. Scalable, very important. Now, what do I mean by scalable? Okay, when you have a website, let's say, for example, www.animeproducts.com. Okay, let's say you have this website that sells anime products, all right? And you would generally want to provision a certain amount of processing power for this website, okay? Depending on the number of people that's visiting it, okay? Obviously, the more people that visit this website, the more computing power you need to give it to serve these customers, right? Now, sometimes you would say you would be able to see things like server overload. Like during game one, sorry, not game one, during the day one of a huge game, right? Everyone logs in at the same time, right? The server is overloaded, cannot handle such a huge load, right? And then it breaks down. Okay, so the good thing about cloud is the server is actually scalable. Whereas if the user increase in size, then you will also increase the server's power. Okay, and when the time comes and you don't need that much power anymore, let's say, for example, after a huge sales, right? So during 6.6, 7.7 and stuff, you may have a huge demand, right? You need to increase the server load, right? You need to scale accordingly. However, after the days of these huge sales, you want it to go back downwards, right? So it's also elastic, where you can ask the user, you can also tell the cloud provider that, hey, I don't need that much server anymore, right? I just need a lower server, sorry, a lower amount of server, and that's it. Okay, I don't need a huge server anymore. Okay, you can scale accordingly, right? And then pay accordingly. Okay, this is used to contrast against the conventional method of having your own personal servers. Okay, I'm not sure if you guys have seen servers before, but I'm just gonna Google it real quick so that you guys can have a look at servers. So I'm not sure if you have seen this in movies or like in your own company as well, right? So you see these kind of servers. So these servers are physical and they are fixed, right? That means if you have a lot of people going on, right, you need a lot of these servers. However, what happens when these people go off, right? When you're no longer in your peak season, okay? A lot of these servers would sit idly, right? They are all idle. IDLE. That means they are not being used, right? Not being utilized. And it's actually a waste of money. Okay. So with the cloud, you can actually scale accordingly to save yourself some money on that end, right? Okay. And third thing that I want to talk about is actually they are very fast. Fast deployment. Okay, what do I mean by this? Obviously, if you want to set up a company and you want to buy these kind of servers, it would take about a month to set up, all right? But if you were to use a cloud to deploy your websites, you can actually do it within like what, 1 or 2 days. I think usually within 1 day itself, you are able to deploy it, right? I'm sure you have uploaded some information onto the Google Drive or Dropbox before, right? It usually takes less than an hour, right? Depending on your file size, of course, right? So using the cloud, it is very fast. Okay, you save a lot of time doing so, right? And in business, time is money, right? The more time you spend on trying to get something to deploy, the more time you're wasting on getting the sales, right? And also, if you're using the cloud, it gives you it provides an easier collaboration. What do I mean by easier collaboration? That means when you upload a file onto Google Drive, for example, or maybe AWS S3 services, right? A lot of different users can have access to this same file, right? And make changes to it, okay? So all of you can work on the same file at the same time, all right? Now, versus the idea of you saving your file in your local computer, okay? And then you have another friend that has a local computer too as well, okay? You need to save your file, all right, pass to him, and then he save his file and then pass back to you in order to make some changes, right? That is a lot of time being consumed, right? A lot of time wasted. So when you upload things onto the cloud, it makes things very easy to just change concurrently, okay? Okay, let's see. Roger said the conventional method is to set up a server like the pay you share in Google. How about cloud server? Is it not physical? Okay, so Roger, to debunk your myth, it is still physical, yes, Vincent. It is also like this. There are a lot of data centers. So let me show you an Amazon data center. Oh, Singapore. Can I see one? Okay. So you can imagine it as like a huge building of different servers, and we are actually using a portion of it for our use, right? We don't need to pay for this building's cost. We don't need to pay for its rental. We don't even need to pay for the water bills or the electricity bills, right? We just pay for whatever computing power that we require. Okay. Now, as compared to having your own physical server, right? The conventional method, you need to pay for the buildings rental. You need to pay for your electricity bill that supports the servers, right? So there's a lot of operational costs that you need to consider. Okay. Now, to sum all of this in one video, all right, I believe a video is actually better than 1,000 words, right? So I will show you guys a video by AWS to explain a bit about cloud computing. Okay, so do let me know if this is lagging, all right?
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business. such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers, so you can focus on what matters most to your business.
Yep. Okay. So with cloud, right, most of your capital expenses can be changed to variable expenses as the video has suggested, right? So what does it mean by that, right? Instead of you paying a fixed amount of money for your rental, for electricity bill and your water bill, you are now paying a flexible amount of money for the amount of IT that you're using. Okay, and also consider this, right? AWS has a team of IT professionals, right? They have IT professionals where you don't actually need to hire your own team of IT professionals anymore, right? Say if anything happens to your servers, right? If your website is not ongoing, right? You can just contact the AWS professional team and they will be able to help you depending on the package that you are with them, all right? So that's that on cloud computing. And why is it so prevalent nowadays, right? Because it really helps a lot of entrepreneurs, right? First-time businessmen, right? First-time entrepreneurs, they are allowed to focus more resources onto their end product than to focus the resources on something that is not their product, which is like rental and stuff, right? These fixed costs are now being minimized because of the appearance of cloud computing. Okay. Now, of course, cloud computing is not a new thing, right? It is not a 2000 kind of thing, right? It has always been there. But why has it boomed up to such fast? Why does it grow in such an amazing speed recently? Because of the improvement of technology, right? Obviously. So back then when Mr. Wawa was trying to connect to an internet, I need to look at two computers connected to each other, sending packets of information to and fro for like 3 minutes just to get connected to the internet. All right. Nowadays, you can just switch up the computer and it's immediately connected to the internet, right? That's how fast internet has grown up to nowadays, right? And it makes it makes the access to cloud services that much more easier right now, right? Back then, imagine this, right? You just have to spend 3 minutes to connect to the internet, not even to get to the AWS services yet, right? So yeah, it has gotten bigger nowadays because internet speeds have been amazing, right? So I'm just going to show you guys one more video before we close this off, which is on what is AWS, right? Because tomorrow you'll be exploring this part of AWS, this management console, where you'll be exposed to a lot of different services, right? At this stage, I think AWS has like 200 plus products, right? And they're categorized in maybe your database, storage, containers, media services, or even machine learning for some of you who are interested in artificial intelligence and machine learning, right? And some of you may be interested into creating VR games. You can explore Amazon Sumerian. There's a lot of things that you can do with it, right? Even analytics, okay? So tomorrow you will have a quick run through on this with Mr. Eric, right? So I'm not gonna go through all of this with you guys, all right? I just wanna give you guys a rough idea on what cloud is, and yeah. So let's go to the next video.
AWS is the world's most comprehensive and broadly adopted cloud platform. Millions of customers trust AWS to power their infrastructure and applications. Organizations of every type and size are using AWS to lower costs, become more agile, and innovate faster. AWS provides on-demand delivery of technology services via the internet with pay-as-you-go pricing. You can use these services to build and run virtually any type of application without upfront costs or ongoing commitments. You only pay for what you use. AWS gives you more services and more features within those services than any other cloud provider. This makes it faster, easier, and more cost-effective to move your existing applications to the cloud and to build anything you can imagine. From infrastructure technologies like compute, storage, and databases, to emerging technologies such as machine learning and artificial intelligence, data lakes and analytics, and Internet of Things. Building on AWS means you can choose the right tool for the job. For example, AWS offers the widest variety of databases that are purpose-built for different types of applications. With AWS, you can leverage the latest technologies to experiment and innovate more quickly. We are continually accelerating our pace of innovation to invent entirely new technologies you can use to transform your business. Like pioneering the serverless computing space with the launch of AWS Lambda, which lets developers run their code without provisioning or managing servers. And AWS built Amazon SageMaker, a fully managed machine learning service that empowers everyday developers and scientists to use machine learning without any previous experience. We are constantly expanding our global network of AWS regions, so you can access AWS services to build and run your applications from anywhere in the world. Each of these regions has multiple availability zones that are physically separated from each other and connected by low latency, high throughput, and highly redundant networking. This makes it easy to design and operate applications that are scalable, fault-tolerant, and highly available. Our infrastructure is built to satisfy the security standards of the most risk-sensitive organizations. You also have access to the AWS Partner Network, which has thousands of systems integrators who specialize in AWS services, and tens of thousands of independent software vendors who adapt their technology to work on AWS. With the largest community of customers across every industry, AWS has unmatched experience and operational expertise you can depend upon for your most important applications in every imaginable use case.
Okay, all right. So I am going to answer a few questions here. So cloud servers is like centralized in one location while many can utilize it from all different locations. So you can imagine there are several data centers across the world. Let me just take a look. There are actually 25 geographical regions for AWS, right? So some of them are in the North America, actually most of them. Some of them in South America, some in Europe, some in Middle East, some in Africa, and some in Asia Pacific as well. Now, why is that so that you need to have different data centers at these regions? Remember, one of the videos actually mentioned latency, okay? The further away the data center is from your region, all right, the latency will be bigger. That means you will take more time to reach the website that you want to go to, right? I'm sure some of you have browsed certain websites that take a very long time to load. Chances are these websites are being hosted in servers that are of a faraway region, right? Let's say, for example, I'm here in Singapore. I'm trying to visit a website that is hosted in North America, right? Obviously, the latency will be there, right? Because I have to travel all the way to North America just to get that piece of information, right? So when you see this kind of latency, that is trying to tell you that your server is a bit too far from the region that you are the region that you are serving, right? So AWS has data centers from across the world that allows you to host your website, all right, at a very fast speed to these particular customers in these regions, right? I think they're called edge locations, right? So you have different edge locations where people around the world can still visit your website as though they are very close to them, okay? Yep. So that will be the end of today's class on functions and scope. Hope you guys are okay with that. So just a quick recap. when you want to define your own function, you use the def keyword followed by your function name, right? Followed by the number of parameters that you want, okay, and followed by a colon. After the colon, there is an indentation, and this is where you then put in your function's body, right? All the actions that you want, okay? And whatever that's inside the function scope, this is all your local variables, right? And it will only exist within the function scope, the local scope. Anything that you declare outside of the function scope, right, on the main program itself, it is called your global variable. That means anyone can use it. Everyone can see it. All right. Local variable are supposed to die off immediately when the function call is done. Okay. So that's it for functions and scope. There will still be one more Python lesson, which is going to be this Saturday, right? Tomorrow, right? The day after tomorrow, or from 10 a.m. to 12 p.m. Okay, it will be on classes and OOP. Okay, OOP stands for object-oriented programming, right? Oop. And yep, it will only be a 2 hours lesson. I'll be talking about classes and instances. And for tomorrow, there will be a class from 7 to 9 on AWS Management Console. Okay, so if you have no more questions for me, I'm going to pass the time back to Ricky or Val. Yeah, Val is here.
My screen.
Sure. Let
Yep.
me stop sharing.